Hello students, this is grade 10 physics class, chapter 12, electricity. In last video class we have seen resistors in series combination. What is that? Resistors in series combination. Yes. In this session we are going to start our next topic, that is resistors in parallel combination. What is that? Parallel combination. Yes. So in order to start next topic, we must recall what are the things we have seen in previous video class. Is it clear, students? Yes. In last video class we have seen resistors in series combination. What is that? Resistors in series combination. Yes. So what is series combination, sir? What is meant by series combination? Yes, the number of resistors are two or more resistors connected n to n consecutively, or we can say one after one consecutively. Then the combination of resistors are said to be in series. In series. Is it clear? Yes. So whenever the resistors are connected one after one, then the combination, then the setup is said to be in series. Is it clear? Yes. So when the number of resistors are connected in series, what happens to voltage, what happens to current and resistors, which means total resistance? Yes, according Ohm's law, so V equal to IR. So when the number of resistors are connected in series, so what happens to voltage and current and the total resistance? Okay, yes, look at here. So when the number of resistors are connected in series, the same amount of current flowing across each resistor. Okay, yes. In series combination, the current remains same. Is it clear, students? Yes. Then what about the voltage, sir? What about the voltage? In series combination, different resistors will have different amount of potential difference, which means generally we say that is voltage. Okay, voltage. Is it clear? Yes. Then what is the total resistance, sir? Because we have connected number of resistors, two or more resistors we have connected in series. Then what about the total resistors? Yes, in total resistors, which is equal to the sum of all the individual resistance. The sum of all the individual resistance. So sum of all the individual resistance, which is equal to total resistance of the circuit in series combination. Is it clear? Yes. So till now we have seen up to this. Is it clear? Yes, look at here. Once again, I'll recall that. Consider three resistors. Consider three resistors. Yes. This is resistor 1. This is resistor 2. And this is resistor 3. Okay? Yes. Resistor 1 is named as R1, resistor 2 R2, and resistor 3 R3. Is it clear? Yes. Look at here. This is one end of the resistor 1. First resistor one end, and this is another end. And this is first end of the resistor 2, and this is another end of the resistor 2. Isn't it? Yes. And next one, this is resistor 3. This is one end of the resistor 3, and this is another end of the resistor 3. Is it clear? Yes. Look at here. Here one end of the resistor 1 connected to other end of the resistor 2. Am I right? Yes. Then the other end of the resistor 2 is connected to one end of the resistor 3. Am I right or wrong? Yes, one end of the resistor 3. Here two or more resistor connected end to end. Am I right? Yes, end to end consecutively. So this combination of resistors is said to be in series. This combination is said to be in series. Is it clear? Or otherwise we can say here first resistor, second resistor is connected after first one, third resistor is connected after first one and second one. So whenever the resistors are connected one after one, note this point, one after one, then the combination of resistor is said to be in series. In series. Is it clear? Look at here. Here the resistors are connected n to n. Am I right? N to n. Yes. One end of the first resistor connected to one end of the second resistor. Another end of the second resistor is connected to first end of the third resistor. So here resistors are connected N to N consecutively. So then the combination of resistors or resistances said to be in series. Is it clear? Yes. In other words, we can say when two or more resistors connected one after one, okay, one after one, then the combination is said to be in series. Is it clear? Not series, series. Is it clear, students? So very easy one. Yes. So next one, the first end, this is resistor 1. The first end of the resistor 1 is connected to the positive terminal of the battery. Look at here. This is resistor 1, first resistor. First end of, this is first end, yes. The first end of the resistor 1 is connected to the positive terminal of the battery. This is positive terminal of the battery. Am I right? Yes. Next one, the last end of the last resistor. This is last resistor, okay, which means third resistor. This another end of the third resistor. So last resistor, last end is connected to the negative terminal of the battery. What is that? Negative terminal of the battery. Then this combination of resistors is said to be in series. Is it clear? This is series. Is it clear? Very, very easy one. Okay, yes. Resistor 1, resistor 2, resistor 3. Here the all resistors are connected N to N consecutively. Or otherwise we can say the all resistors are connected one after one. So then the combination of resistor is said to be in series. Is it clear? Yes. Then one end of the first resistor is connected to positive terminal of the battery, and other end of the last resistor is connected to negative terminal of the battery. Negative terminal of the battery. Is it clear? Yes. So this circuit, this design is for only resistors in series. Is it clear? Yes. That's all. Okay, yes. Next one. So when the number of resistors, which means two or more resistors connected in series, what happens to voltage and what happens to current and what happens to resistance? Okay, because according Ohm's law, V equal to IR. According Ohm's law, so V equal to IR. Voltage is equal to the product of current and resistance. Is it clear? Yes. Here we have connected more resistors, two or more resistors in series. So when we connect the two or more resistors or number of resistors connected in series, what happens to voltage and what happens to current as well as resistance? Look at here. Yes. Here. So whatever the resistance connected in series, same amount of current flowing across the each resistor. Now this point, same amount of current flowing through the each resistor. Is it clear? Yes. So already we know the current always flows from positive terminal of the battery to negative terminal of the battery. Am I right? Yes. So positive terminal of the battery to negative terminal of the battery. Current always flows from positive to negative terminal of the batteries. Isn't it? Yes. Look at here. Here we have connected three resistors, R1, R2 and R3. R3. So we have connected three resistors. You just consider the three resistors value is different, not same. Value is different. Is it clear? Yes. But the current flowing through the each resistors will be same. Will be same. Suppose throughout the circuit 4 ampere current is flowing. 4 ampere current is flowing. Yes. So what about the current value in a resistor 1, sir? Resistor 1 also the 4 ampere current will flow. Yes. So here also current will flow. Same amount of current will flow. Here also same amount of current will flow. Here also same amount of current will flow. Which means across the resistor R1 the 4 ampere current will flow. Across the resistor R2 the same 4 ampere current will flow. Third one, across the resistor R3 the same amount of 4 ampere current will flow. So whenever the resistors are connected in series, the same amount of current will flow across the all the resistors. Across the all the resistors. This is very, very important point. Keep this point always in your mind. Okay, look at here. So whatever the resistors connected in series, the same amount of current flowing across the each resistor in series combination, only in series combination. Is it clear, students? Yes. Okay, sir. Current, okay, sir. What about the voltage, sir? What about the voltage? According to Ohm's law, V equal to IR. So I, we have seen about I, which means current through the series combination of resistors. Then what happens to voltage? What happens to voltage? Yes, look at here. So we apply voltage. We apply voltage by battery, which means potential. Generally we say that is potential difference by this battery. Is it clear? Yes. Here the potential, here we have connected three resistors R1, R2 and R3. Am I right? Yes. Here the different resistors will have different amount of potential difference. Note this point. We have connected three resistors in series. Yes. Here the different resistors will have different potential difference, which means the resistor R1 will have V1 potential difference. Okay, yes, so across the resistor R1. Then the resistor R2 will have different potential difference, so it will be V2. It will be V2. Then the resistor R3 will have the different potential difference, that is V3. That is V3. Okay, look at here. This is main voltage. The main voltage which is supplied by the battery. Yes, so when the number of resistors connected in series, this main voltage gets distributed. Note this point. The main voltage gets distributed as in the form of V1, V2 and V3. Here in series combination, this potential difference is depend on the resistor's value. Potential difference is depend on this resistor's value. Is it clear, students? It's very easy. Okay, yes. Then the sum of all the potential difference across the each resistors will be equal to this total potential difference. Will be equal to this total potential difference. So the total potential difference, that is V. The total potential difference which is supplied by the battery, that is V. But here the total potential difference gets distributed as in the form of V1, V2 and V3 across the each resistor. Am I right? Across the each resistor. So the sum of all the potential difference across the all resistors will be equal to total potential difference supplied by this battery, which means total potential difference V, that is equal to V1 plus V2 plus V3. V1 plus V2 plus V3. So what is the potential difference across the resistor R1? That is V1. The potential difference across the resistor R2, that is V2. Then potential difference across the resistor R3, that is V3. So if we add this all potential difference value across the all resistor, that will be equal to total potential difference supplied by the battery. Is it clear? Note these points, very important point. See, in 10th standard, the electricity, especially in electricity line, most of the numericals, most of the questions comes from only this part, only series combination as well as in parallel combination. Most of the questions will come from only this both concept. Okay, so please give more important for this two combination, which means series combination as well as parallel combination. Okay, students, it's very easy. Okay, yes. Then look at here. So according to Ohm's law, so V equal to IR. So now we have discussed about V as well as I, current. Then what about the resistance, sir? What about the resistance? Look at here. We have three resistors. We have three different values of resistors R1, R2 and R3. Then what is R value, sir? Which means total resistance, sir. Total resistance. Look at here. For example, consider the R1 value is 1 ohm. The resistor R1 value is 1 ohm. You just consider. This is for an example. Then the resistor R2 value is 2 ohm. 2 ohm. Then resistor R3 value is 3 ohm. Okay. Look at here. We have three different resistors. First resistor value is 1 ohm. Second one 2 ohm. And third one 3 ohm. So we have three different values of resistors. Isn't it? Yes. Then what is the total resistance in this combination, sir? You tell me. What is the total resistance value in this combination, which means series combination? Yes. The total resistance in series combination, which is equal to sum of all the resistors value. That's all. Sum of all the resistors value. Look at here, the total resistors. Note this point, very important one. The total resistance in series combination are, which is equal to sum of individual resistances. Okay, which means R1 plus R2 plus R3. So if we add this all resistors value, we can get the total resistance value in series combination. In series combination. Is it clear, students? Very easy. Please don't get panic. Okay, don't get panic. So now what is R1 value? R1 value is 1 ohm, R2 value is 2 ohm, R3 value is 3 ohm. Am I right? Yes. So add this all values. So what will be there? What will be the total resistance value? 1 plus 2 plus 3. What will be the value? That is equal to 6 ohm. That is equal to 6 ohm. So here the total resistance value is 6 ohm. Total resistance value is 6 ohm. Is it clear? Yes. So whatever the resistance connected in series, you just add the all resistance value, that will be equal to total resistance value. Is it clear? This very easy one. You don't get panic. Please try to understand my concepts, what I am telling here. Please try to understand my concept. That's all about series combination. That's all about series combination. Okay, yes. So this total, the sum of the all potential difference across the resistors will be equal to total potential difference, that is V, that V supplied by the battery. Okay, so I don't have space, so you adjust that. Okay, students, that's all about series combination. Is that clear? A very easy one. Okay, so what is the conclusion, sir? What is the conclusion? First of all, what is series combination? So when two or more resistors connected n to n consecutively, then the combination of resistors is said to be in series. In other words, we can say when the resistors are connected one after one, know this point, when the resistors are connected one after one, then the combination is said to be in series. That's all. In series. Okay, yes. Then the first end of the first resistor is connected to the positive terminal of the battery, then last end of the last resistor is connected to the negative terminal of the battery. Is it clear? So this is the design of resistors in series combination. Is it clear? Yes. According Ohm's law, V equal to IR. So when the number of resistors, which means two or more resistors connected in series, what happens to voltage and what happens to current as well as resistors? That is main concept. Okay, yes. Look at here. So when the number of resistors are connected in series, the same amount of current is flowing through the all resistors. Note this point, very important. When number of resistors are connected in series, the same amount of current is flowing across each resistor. Okay, yes. So in series combination, current remains same. So whatever the resistance, current remains same. Yes. Next one, voltage. What happens to voltage, sir? What happens to voltage? When two or more resistors connected in series, the voltage gets distributed. Voltage gets distributed. Yes. So look at here. Across the resistor R1, the voltage will be V1. Across the resistor R2, the voltage will be V2. And across the resistor R3, the voltage will be V3. The voltage will be V3. Okay. Yes. So if we add these three potential difference value, okay, which means V1 plus V2 plus V3, we can get the total potential difference in the circuit. That total potential difference, which is equal to the voltage supplied by the battery. The voltage supplied by the battery. Is it clear? It's very easy one. So in series combination, voltage gets distributed. Voltage gets distributed. In series combination, the voltage drop, that is depend on resistance value. Voltage drop is depend on resistance value. Is it clear, students? It's very easy. Next one, what happens to resistance, total resistance? Look at here. We have connected three different resistors. The three different resistors will have resistance value. Am I right? Yes. First resistor value is 1 ohm, second 2 ohm, and third one 3 ohm. Is it clear? Yes. Then what is the total resistance, sir? You just add this all resistor value, we can get the total resistance value. That's all. That's all. So when two or more resistors connected in series, the total resistance will be equal to sum of individual resistance value. That's all. The sum of individual resistance value, which means total resistance R, that is equal to R1 plus R2 plus R3. That's all. Very, very easy. Okay, yes. In series combination, current remains same, but voltage gets distributed. And resistance total resistance, which is equal to sum of all the resistors connected in series, which means the sum of individual resistance value. That's all. You just add the all resistance value. That's all. Okay. Yes. So that's all about the series combination. Okay, students. Yes, this is a basic to understand the concept of parallel. Yes. So in this session, we are going to start with the next topic, that is resistors in parallel. Resistors in parallel. This is very, very important one. Very, very important one. After series combination, this is very important topic. Is it clear? Yes. So this is series. This is series combination. Yes. With the help of the series combination, we are going to understand easily what is parallel combination. Okay. Yes. Look at here. So next we are going to start with today's class, resistors in parallel. What is that? Resistors in parallel. Is it clear? Yes. Yes. You just consider three resistors. Consider three resistors. Yes. So this is resistor 1, resistor 1, this is resistor 2, and this is resistor 3. Okay, look at here. Now we are going to start with resistors in parallel combination. Is it clear? Yes. You just consider three resistors. First one, second one, and third one. Okay, first resistor, consider this is R1, and second resistor, this is R2, and third resistor, this is R3. Is it clear? R1, R2, and R3. Yes. Each resistor, note this point, each resistor has two end. Yes, this is first resistor. The first resistor has two end. This is first end, and that is second end. The second resistor has two end. This is first end, and that is second end. Yes, obviously the third resistor also has two end. This is first end, and that is second end. So each resistor has two end. Two end. Am I right or wrong? Yes, obviously each resistor has two end. Is that clear? Yes. Look at here. Now we are going to see parallel combination. Parallel combination. Yes. Look at here. One end of the all the resistor. One end of the all the resistor. You just consider the left hand side end. Okay. This means this end, and that end. Okay. Yes. You just consider one end of the all the resistor. Resistor 1, resistor 2, and resistor 3. Yes. One end of the all the resistors is connected to a single point. Look at here. One end of the all the resistor connected to a single point here. Okay, here resistor 1, resistor 2, resistor 3. This is one end of the resistor 1, another end of the one end of the resistor 2, as well as this one end of the resistor 3. Yes. So one end of the all the resistors connected to a single point here. Single point here. Is it clear? Yes. Consider this point is A. That point is A. Okay. Yes. Next come to another end. Next come to another end of the all the resistor, which means the right side end of the all the resistor. Yes, look at here. The another end of the all the resistor, note this point, the another end of the all the resistors are connected to a single point. The another end, so this is first end and that is second end. So this another end of the all the resistors are connected to a single point. Okay, consider that point is B. That point is B. Okay, look at here. So when two or more resistors are connected between same 2 points, this is point A and that is point B. Am I right? Yes. So whenever two or more resistors are connected between same 2 points, then the combination of resistor is said to be in parallel. Very simple. That is parallel. Okay. Yes. Look at here. Here the point A. The point A is connected to the positive terminal of the battery. Now this point, this is point A. All the resistors one end connected to the point A. Yes, this point A, which means the one end of the all the resistors are connected to the positive terminal of the battery. Is it clear? Yes. Next one, the other end of the all the resistors. Okay, I think it's not straight line. Look at here, the other end. Now it's okay. The other end of the all the resistors. The other end of the all the resistors are connected to the negative terminal of the battery. What is that? Negative terminal of the battery. Is it clear? This combination is said to be in series, students. That's all. Very easy one. Look at here. So when two or more resistors, note this point, when two or more resistors connected between same 2 points, this is point A, one end of the all the resistors are connected to point A and other end of the all the resistors are connected to point B, then the two ends are connected to the two terminals of battery. Two terminals of the battery. Is it clear? Yes. So when the two or connects are connected between the same 2 points, what is that? Same 2 points, then the combination of resistors is said to be in parallel. Parallel. Is it clear, students? Very easy one. Or otherwise, in other words, we can say when one resistor is connected below 1, okay, which means the resistors are connected 1 by 1 or 1 below 1, then the resistors combination is said to be in parallel. Okay, generally what is the word meaning parallel? Parallel means nothing but this is parallel. Two lines are horizontal. Two lines are horizontal. So here also two lines are placed 1 below 1. Okay, 1 below 1. So this is parallel combination. Am I right? This is parallel combination. The same. Okay, the same procedure is happening here. Here one resistor is connected. One resistor is connected, so below 1. Below 1. Okay, look at here. Here the R1 resistor is parallel to R2 as well as R3. The R2 resistor is parallel to R1 as well as R3. The R3 resistor is parallel to R2 as well as R1. So here the resistors are parallel to each other. Am I right or wrong? All the resistors are parallel to each other. So this setup, this combination is said to be in parallel connection or parallel combination. That's all. Parallel combination. Is that clear? Very easy one. Okay, yes, look at here. Next we are going to see resistors in parallel. Okay, yes, consider 3 resistor. This is resistor 1, resistor 2, resistor 3, R1, R2 and R3. Each resistor has 2 end. This is first end of the all the resistor and this is another end of the all the resistors. Is it clear? Yes. Look at here. Now you consider this one, this side of the end. Okay, this end. Okay, yes. Here, the one end of the all the resistor, which means left hand side. The one end of the all the resistors are connected to a single point. That is point A. Am I right? Yes. Next, come to this one. The other end of the all resistors. The other end of the all the resistors are connected to a same point. That is B. That is B. Okay, students? Yes. Look at here. Next, the one end of the all the resistors are connected to the positive terminal of the battery as well as the other end of the all the resistors are connected to the negative terminal of the battery. Negative terminal of the battery. Okay, yes. Look at here. Here, the all the resistors one end directly connected to the positive terminal of the battery. Okay, yes. Similarly, the other end of the all the resistors are directly connected to the negative terminal of the battery. Am I right? Directly, note this point, very, very important point. Directly connected to the negative terminal of the battery as well as positive terminal of the battery. Is that clear? This combination is said to be in parallel combination. Parallel combination. So when, note this point, when 2 or more resistors connected between same 2 points, between same 2 points along with this battery, then the combination is said to be in parallel. Then the combination is said to be in parallel. Okay, just look at here. Or otherwise, in other words, we can say, so when the resistors are connected 1 below 1, then the combination is said to be in parallel combination. Okay, yes, look at here. Here the R3 R3 is connected so below R2. Am I right? Yes. So R2 is connected below R1. Am I right? Yes. So R1 resistor is parallel to R2 as well as R3. R2 resistor is parallel to R1 as well as R3, and R3 resistor is connected to R3 resistor is parallel to R2 as well as R1. Each resistor is parallel to each other. Am I right? Each and every resistor is parallel to each and every other resistors. Then this combination of a resistor is said to be in parallel. Okay, look at here. So what is the difference between this parallel and series? Parallel and series. Look at here. All the resistors are indirectly connected between positive and negative terminal of the battery. Am I right? All the resistors, note this point, very very important point. In series connection, all these resistors are indirectly connected between the positive and negative terminal of the battery. Whereas in parallel combination, all the resistors are directly connected between the two terminals of the battery, which means positive terminal and negative terminal of the battery. Am I right or wrong? Yes, look at here. This one end of the all the resistors connected to the positive terminal of the battery. Other end of the all resistors are connected to the directly connected to the negative terminal of the battery. Whereas look at here the first resistor first end only is directly connected to the first resistor first end is directly connected to the positive terminal of the battery. Here last resistor last end is directly connected to the negative terminal of the battery, and remaining this end never connected to the terminals of the battery directly in series combination. But in parallel, all the resistors directly connected between the two terminals of the battery. Is it clear, students? Yes. So this combination is said to be in parallel. That's all. Okay, it's very easy one. So look at here. So what is the content, sir? What is the series combinations of when two or more resistors connected in same 2 points along with, note this point, along with these two terminals of the battery, then the combination of the resistors is said to be in parallel. Okay, or otherwise we can say, so the number of resistors are connected one below one, then the combination of the resistor is said to be in parallel. Is it clear? Yes, look at here. This R1 is parallel to R2, R3 is parallel to R1, R2. Okay, so each resistor is parallel to each other. Okay, so this combination is said to be in parallel. So never ever forget this concept. Okay, students? Yes, look at here. Yes, so we have connected the three resistors in parallel. Okay, yes. So what happens to voltage, sir? What happens to current, sir? And what happens to resistors, sir? That is next question. Okay, this is series combination. Okay, we have discussed about series combination. In parallel combination. Okay, this is parallel combination. That is series combination. This is parallel combination. Okay, so when two or more resistors are connected in parallel, what happens to voltage and what happens to current and what happens to resistance, sir? That is next question. So according Ohm's law, V equal to IR. Okay, yes. So when number of resistors are two or more resistors connected in parallel, what happens to voltage and what happens to current and what happens to resistors? That is next question. Now we are going to see one by one. Okay, like series combination. Is it clear, students? Yes. First we will start with voltage. Is it clear? So what is the contents are here? So when two or more resistors connected in parallel, what happens to voltage? That is first one. Okay, students? Yes. First we will see about voltage. Okay. Yes. Look at here. So this voltage is supplied by always this battery. battery. Is it clear? Yes, voltage is always applied by the battery, which means generally is a potential difference. The potential difference is produced by the battery cell or any other power generator. Is it clear? Yes. So this is a parallel combination setup. This is a parallel combination setups. Look at here. So we apply the voltage. We apply the voltage by this battery. By this battery. Is it clear, students? Yes. Look at here. We apply 10 volt. This is for an example. Okay, not exact meanings. For an example, for your clear understanding purpose. Okay, students. Yes. Here we apply 10 volt potential difference, which means 10 voltage throughout the circuit. Throughout the circuit. Is it clear? How much voltage we apply? We apply 10 volt potential difference throughout the circuit, throughout the combination of resistors in parallel circuit. Is it clear? Yes. So already we know the positive terminal is the high potential and negative terminal is the low potential. Yes, obviously the positive terminal in the battery or any other power source, that is high potential, and negative terminal is a low potential. Okay, which means positive is a high pressure and negative is a low pressure, because potential difference is a kind of pressure which push the all electrons to flow in a particular direction. Is it clear? Yes, look at here. So the end of the resistors are connected to the single point, that is A, and all the end of the other end of the resistors connected to the single point, that is point B. Point B. Okay, so look at here. So all the resistors one end directly connected to the positive terminal. Am I right or wrong? Look at here. The one end of all the resistor. The one end of all the resistor are directly connected to the positive terminal of the battery. Am I right? Yes. Next one, the other end of all the resistors are directly connected to the negative terminal of the battery. What is that? Negative terminal of the battery. Am I right or wrong? Yes. So look at here. So we apply 10 volt potential difference throughout the circuit, throughout the parallel combination circuit. Am I right? Yes. Here the positive terminal. So from the positive terminal of the battery there will be potential. Okay, there will be some amount of potential. Yes. So from the negative terminal of the battery there will be some amount of potential difference. Some amount of potential difference. Am I right? At the point B, some amount of potential difference, because positive terminal is the high potential and negative terminal is the low potential. Is it clear? Yes. Look at here. So when we apply 10 voltage potential difference, okay, throughout the circuit, throughout the parallel combination of resistors, each resistor will have, note this point, each resistor will have same amount of potential difference. Each resistor will have same amount of potential difference, which means if we apply the 10 volt potential difference by this battery, each resistor will have same amount of potential difference, which means across the resistor R1 the potential difference will be same 10 volt which is applied by the battery, and across the resistor R2 the same amount of potential difference will be there, as well as across the resistor R3 the same amount of potential difference will be there, that is a 10 volt. That is 10 volt. Okay, look at here. So when two or more resistors connected in parallel, the same amount of potential difference is there across the all resistors. Same amount of potential difference is there. Okay, yes. So across the resistor R1 the same 10 voltage potential difference is there. Across the resistor R2 the same amount of 10 voltage potential difference is there, as well as across the resistor R3 the same 10 voltage potential difference is there. Okay, yes. So whenever the number of resistors are connected in parallel, the same amount of, note this point, the same amount of potential difference is there across the all resistors. Same amount of potential difference is there across the all resistors. Is it clear? But come to series combination. In series combination, voltage gets distributed. Am I right? Voltage gets distributed. Is it clear? Yes. But in parallel, voltage remains same. Voltage remains same. Is it clear? Yes. Next question rising here. Sir, why voltage is same, sir? Next question rising here. Why in parallel combination voltage remains same across all the resistors? Why, sir? Why? That is very big question. Okay, look at here. Why? Because the one end of all the resistors are directly connected to the positive terminal of the battery, whereas another end of all the resistors are directly connected to the negative terminal of the battery. Look at here. Here we have applied 10 volt potential difference throughout the circuit. So each resistor in parallel combination will have the same amount of potential difference which is supplied by the battery. That's all. Which is supplied by the battery. Okay, so only one main concept is all the resistors are directly connected to the, what is that, positive terminal of the battery, and another end of all the resistors are directly connected to the negative terminal of the battery. That is the reason. That is the reason. Is it clear? It's a very, very easy one. So that is the reason why. So whenever the two or more resistors are connected in parallel combination, each resistor will have same amount of potential difference. Each resistor will have same amount of potential difference. If you apply 10 volt potential difference throughout the circuit, the resistor 1 will have the 10 volt potential difference. Then resistor 2, which means R2, will have same amount of potential difference, that is 10 volt. Then the resistor 3, R3, will have the same amount of potential difference, that is 10 volt. Because all the resistors are directly connected to the positive terminal of the battery as well as negative terminal of the battery. That is the reason. But in series combination, come to here. In series combination, all the resistors are indirectly connected. Note this point. All the resistors are indirectly connected along with these two terminals of the battery. Am I right? That is the reason why in series combination the voltage gets distributed, whereas in parallel combination voltage remains same. So whatever the resistance value in parallel combination. That's all, students. A very, very, very easy one. Okay. Yes. Look at here. Let's take example. At point A, the potential difference is 50 volt. At point A, the potential difference is 50 volt, whereas at point B, the potential difference is 10 volt. At point B, the potential difference is 10 volt. Is it clear? Yes. What is the potential difference, sir? Now you tell me, what is the potential difference? Already we know potential difference means there must be two things. Am I right? There must be two things, which means difference. The word difference, which means what is that? There will be two things. Am I right? Yes. You just consider the resistor R1. Now you consider resistor R1. Resistor R1. So across the resistor R1, what is the potential difference? Note this point. Now we are going to prove how in parallel combination the different resistors will have different resistors will have same amount of potential difference. Now we are going to prove that. Okay, students. Yes. Look at here. All the resistance one end connected to the point A, and all the resistance another end connected to the point B. Point B. Is it clear? Yes. At point A, the potential difference is just for an example, 15 volt. At point B, the potential difference is 10 volt. 10 volt. Yes. Now we are going to find out what is the potential difference across the resistor R1. Across the resistors, this R1 only. Okay, students. Yes. So look at here. So the potential difference which is equal to, what is that? Yes. The one end of the resistor RA is connected R1. One end of the resistor R1 is connected to the point A, and other end of the resistor R1 is connected to point B. Am I right? Yes. At point A, the potential difference is 15 volt. At point B, the potential difference is 10 volt. Yes. Already we know we always minus from high potential to low potential. Am I right? High potential to low potential. Here, which is high potential? A is high potential and B is low potential. So potential difference across the resistor R1, which is equal to VA minus VB. VA minus VB, because A is a high potential, B is a low potential. So VA minus VB. Yes. So at the point A, okay, VA means what is that? Potential difference at the point A. VB means potential difference at the point B. That is the reason why I have mentioned VA and VB. Okay. Yes. So at point VA, what is the potential difference? Yes, 15 volt minus at point B, what is the potential difference? 10 volt. 10 volt. So what is the potential difference across the resistor R1? That is potential difference, that will be 5 volt. That will be 5 volt. Is it clear, students? Yes. So look at here. So across the resistor R1, the potential difference is 5 volt. 5 volt, isn't it? Yes. Now what is the potential difference value across the resistance R2? Okay, first one R1 completed. Across the resistor R1, the potential difference is 5 volt, isn't it? Yes. Now you find out what is the potential difference across the resistor R2. This is R2, isn't it? Yes. Now find out resistor R2. Resistor R2. Okay, students? Yes. R2. Yes. Obviously the potential difference which is equal to what is that? High potential minus low potential, isn't it? Yes. So consider this is R2. One end of the resistor R2 is connected to the point A, and other end of the resistor R2 is connected to the point B. Am I right? Yes. So these two ends are connected along with these two terminals of the battery directly. Am I right? Yes. So at point A, what is the potential difference of this resistor R2? The same 15 volt. Yes. So here also, so look at here, potential difference, which means VA minus VB. Because one end of the resistor R2 is connected to the point A, and other end of the resistor R2 is connected to the point B. At point A, the potential difference is 15 volt. At point B, the potential difference is 10 volt. Am I right? Yes. So we always minus from high potential to low potential. So VA minus VB. At point A, what is the potential difference? 15 volt. Yes, 15 volt minus at point B, what is the potential difference? That is 10 volt. 10 volt. Yes. So here what is the potential difference across the resistor R2? 15 volt minus 10 volt, which is equal to 5 volt. 5 volt. So across the resistor R2, the potential difference value is 5 volt. Am I right? Yes. So look at here. So the across the resistor R1, the potential difference value is 5 volt. Across the resistor R2, the potential difference value is 5 volt. The same 5 volt. These two resistors will have same 5 volt, 5 volt. Then what about the resistor R3, sir? What about the resistor R3? Yes, we will find out. Look at here. Here I don't have space, so I'll write here. Resistor R3. Resistor R3. Is it clear, students? Yes. So this is resistor R3. So one end of the resistor R3 is connected to the point A, and other end of the resistor R3 is connected to the point B. Am I right? Yes. So directly all the resistors, one end connected to the positive terminal of the battery, and other end connected to the negative terminal of the battery. Am I right? Yes. Look at here. So one end of the resistor R3 is connected to the point A. At point A, potential difference is 15 volt. Yes. Other end of the resistor R3 is connected to the point B. At point B, the potential difference is 10 volt. Am I right? Yes. Now we are going to find out, so what is the potential difference value across the resistor R3? Across the resistor R3. Is it clear, students? Yes. So potential difference which is equal to VA. Am I right? So VA, because one end of the resistor is connected to the point A. So potential is V. So VA here minus VB. Other end of the resistor R3 is connected to the point B, so minus VB. So we always minus from high potential to low potential. A is high potential and B is low potential. So is it clear? Yes. So VA value how much? The same 15 volt minus VB value is same 10 volt. So what is the value, sir? There will be 5 volt. There will be 5 volt. So look at here. This is a proof. This is a proof. So here each resistor will have same amount of potential difference, that is equal to the potential difference supplied by the battery. That's all. Supplied by the battery. Is it clear, students? Very easy one. So what is the content, sir? What is the conclusion, sir? When two or more resistors connected in parallel, across the each resistor, same amount of potential difference will be there. Across each resistor, same amount of potential difference will be there. Why, sir? Why? Because the one end of all the resistors are connected to directly connected to the positive terminal of the battery, whereas other end of all the resistors are directly connected to the negative terminal of the battery, due to which all the resistors will have same amount of potential difference which is supplied by the battery. If we apply 10 volt throughout the circuit, each resistor will have same amount of potential difference, which means resistor R1 will have 10, R2 will have 10, R3 will have 10. So this is the proof. This is the proof. Okay, this is for an example. This is for an example. So look at here. Look at here. So look at here. Across the resistor R1, the potential difference 5 volt. Across the resistor 2, the potential difference is 5 volt. Across the resistor 3, the potential difference is 5 volt, 5 volt, 5 volt, 5 volt. That's all. This is a proof. That is the proof, my dear students. That's all. Okay, very, very easy one. Okay, yes. So I'll rub this. Okay, yes. So this is a proof. You don't get confusion. Okay, students, very easy one. So we have discussed about the voltage. When number of resistors are connected in parallels, what happens to voltage? Isn't it? Yes, that's all. So what is the conclusion, sir? What is the conclusion? So when two or more resistors are connected in parallel combination, each resistor, note this point, each resistor will have same amount of potential difference. That potential difference which is equal to this voltage applied by the battery. If we apply, note this point, if we apply 10 volt potential difference across this circuit, okay, which means throughout the circuit, each resistor will have the same 10 volt potential difference. Same 10 volt potential difference. Is it clear? Which means a resistor R1 will have same potential difference, that is equal to 10 volt. Then the resistor R2 will have same potential difference, that is 10 volt. Then resistor R3 will have the same potential difference, that is 10 volt. Why, sir? Next question raised here. Why, sir? The number of resistors in parallel, each resistor will have same potential difference, sir. Why, sir? Why? Because look at here, the one end of all the resistors are directly connected to positive terminal of the battery, and other end of all the resistors are directly connected to the negative terminal of the battery. Okay, so battery which is used to produce a potential difference. So all the resistors are directly connected along with the two terminals of the battery, due to which, so whatever the resistors are connected in parallel, each resistors will have same amount of potential difference. That's all. Same amount of potential difference. Is it clear? Yes. So in parallel combination, voltage remains same. In parallel combination, V remains same. So whatever the resistors are connected in parallel, voltage remains same across each resistor. Remains same. That's all, students. This is the content. This is the content. Okay, but in series combination, voltage gets distributed. Am I right? Voltage gets distributed. This is the main voltage. Here, this main voltage gets distributed across each resistor. Am I right? Across each resistor. So across the R1 resistor, the potential difference V1 in series here. Across the resistor R2, potential difference V2. Across the resistor R3, potential difference is V3. Why, sir? Why in parallel combination voltage remains same, whereas in series combination voltage gets distributed? Because look at here. The resistors are never directly connected to the two terminals of the battery. They are indirectly connected to the two terminals of the battery. Am I right or wrong? Yes, they are indirectly connected to the two terminals of the battery. Isn't it? Yes. So here in series combination, this voltage value is depend on the resistance value. Resistance value. Is it clear, students? Yes, that's a very easy one. Okay, yes. Now come to here parallel. In parallel combination, when two or more resistors are connected in parallel, when two or more resistors are connected in parallel, each resistor will have same amount of potential difference. That potential difference which is equal to the voltage supplied by the battery. If we apply 10 volt potential difference in the circuit, each resistor will have the same 10 volt potential difference. Same 10 volt potential difference. Is that clear? Because all the resistors are directly connected along with the two terminals of the battery. That is a reason why in parallel combination voltage remains same. Voltage remains same. Keep that in your mind. Okay, yes, that's all. Next one, so voltage, okay sir. Voltage, okay sir. What happens to current, sir? What happens to current? Yes, voltage, okay. Voltage completed. Now we have discussed about voltage in parallel combination. So what happens to current, sir? What happens to current? That is very big question. Okay, yes, look at here. I'll rub that, the unnecessary words. Okay, yes, look at here. This is R2. This is R1. Okay, yes. So what is same here? What is constant here? In parallel combination, voltage is constant. Voltage is constant. Is it clear? Yes. Next, we will move on. Current. What happens to current, sir, in parallel combination? Look at here. Here, all the resistors, two ends are connected between two terminals of the battery. Positive terminal as well as negative terminal of the battery. Am I right? Yes. So when we apply the potential difference from this point, we apply potential difference, that is 10 volt. When we apply the potential difference across the terminals of the resistors, what will happen? There will be current. There will be current. Am I right or wrong? Yes, there will be current, because what causes current? The potential difference causes current. So when we apply the potential difference in electric circuit, what will happen? There will be the flow of charge. So due to this flow of charge, there will be current value, because already we know the flow of electron is called current. Am I right? Yes. So there will be current value. So already we know the current always flows from positive terminal to negative terminal. This is positive terminal. Yes. Current always flows from positive terminal of the battery to negative terminal of the battery. Negative terminal of the battery. Is that clear, students? Yes. Look at here. Here we apply the potential difference 10 volt. We apply potential difference 10 volt. So due to which, this point, due to which 6 ampere current flowing. Know this point. We apply the 10 volt potential. This is for an example. I am telling here example for your understanding purpose. Is it clear? It's not an exact value. Okay. Yes. So we apply 10 volt potential difference. Okay, we apply 10 volt potential difference by this battery. So due to this potential difference, 6 ampere. How much? 6 ampere current flowing. 6 ampere current flowing. The current flowing starts from the positive terminal to negative terminal. So current is coming here and here and here and come to here. Now the current comes to point A. Now current comes to point A. Then what happens to next, sir? What happens to next? Look at here. Now this is for an example. Yes. Now the 6 ampere current is here. The 6 ampere current is here at point A. But look at it. There are 3 paths to current flowing. There are 3 paths, which means R1, R2 and R3 is here. There are 3 paths are there to current flowing. Now what happens to current, sir? Now what happens to current, sir? Yes, look at here. Here in series combination, the current gets distributed. Now this point, we applied 10 volt potential difference by this battery. Okay, due to this 10 volt potential difference, 6 ampere current is flowing from positive terminal to Okay, current is flowing from positive here and here. Come to here. Current comes to point A. Current comes to this point A. But from the point A, 3 branches are there. 3 paths are there. Am I right? This is path 1, path 2, path 3. Resistor R1, R2, R3. Am I right? But the 6 ampere current is here at point A. This is for an example. Okay, 6 ampere current is here. But there are 3 paths. Next, what will happen? Yes, the current gets distributed. Okay, yes. So look at here. Across the R1, so across the resistor R1, the current gets distributed in the form of I1. Across the resistor R2, the current gets distributed in the form of I2 and across the resistor R3 the current gets distributed in the form of I3. Why sir? Why sir? Because look at here, because there are three paths to current flowing. There are three paths to current flowing, due to which current gets distributed. Current gets distributed. So across the resistor R1 the current I is flowing, across the resistor R2 current I2 is flowing, across the resistor R3 current I3 is flowing, because there are three paths to current flowing. There are three paths to current flowing. Is it clear, students? There are three paths to current flowing. That is the reason why current gets distributed. Current gets distributed. Is it clear? Look at here. Now come to series. Look at here. Already we know the current always flows from positive terminal to negative terminal. Current always flows from positive terminal of the battery to negative terminal of the battery. That is one cycle. Am I right? Yes. Look at here. In series combination, we apply the potential difference. Due to the potential difference, current starts flowing from positive terminal to negative terminal. How many paths are there? How many paths are there in series combination? Just only one path is there. Am I right? Yes. Just only one path is there to current flowing. That is the reason why in series combination current remains same. Current remains same. So current always flows from positive terminal to negative terminal. So that is the reason why in series combination, so whatever the resistance, same amount of current is flowing through the each resistor. Same amount of current is flowing through the each resistor. Is it clear, students? There is only one path. So current always flows from positive terminal to negative terminal. This is one cycle. There is only one path to current flowing. So in series combination, the same amount of current flowing through the all resistors. That's all. That is the reason why in series combination current remains same. But come to parallel. Here there are three paths. To current flowing. That is the reason why current gets distributed. Am I right? Yes. So look at here. Across the resistor R1, I1 current is flowing. Across the resistor R2, I3 current is flowing. Across the resistor R3, I3 current is flowing. But 6 ampere is a total current. Know this point. 6 ampere is a total current which is flowing through the entire circuit. But each resistor will have different amount of current, because current in parallel combination current gets distributed. Is it clear? Yes. In parallel combination. In parallel combination current gets distributed. In parallel combination this current value is depend on the resistance value. The current value is depend on the resistance value. If the resistance value is more, then current value will be less. If the resistance value is less, current value will be more. Okay, look at here. So for example, this is for an example. Okay, students, yes. The R1 resistance value is 1 ohm. The R2 resistance value is 2 ohm. The R3 resistance value is 3 ohm. Okay, R1 resistor value is 1 ohm, R2 2 ohm, and R3 3 ohm. Is it clear, students? Yes. So already we know in parallel combination current gets distributed, because there are three paths to current flowing, due to which the total current I gets distributed in the form of I1, I2 and I3. Okay, but look at here, but the 6 ampere is a total current. 6 ampere is a total current which is flowing through the entire circuit. Yes. So already we know we apply 10 volt potential difference by this battery, due to which current is flowing. So 6 ampere current is flowing, okay, throughout the circuit. So current always flows from positive terminal to negative terminal. So at the point 6 ampere current is flowing. At the point the current value is 6 ampere, but after this point there are three paths for current flowing. So current gets distributed as in the form of I1, I2 and I3. Is it clear, students? Yes. Look at here. So according Ohm's law, I equal to V by R. Current value is inversely proportional to resistance. If resistance increases, current will decrease. If resistance decreases, current will increase. Am I right or wrong? Yes. Look at here. Here the resistor R1 value is What is that? Resistor R1 value is 1 ohm, R2 value is 2 ohm, R3 value is 3 ohm. Here which resistor value is more? The R3, and after that R2, after that R1. So at the point A, 6 ampere current is flowing, then after the point A, current gets distributed I1, I2, I3, isn't it? Yes. So across the resistor R1, here 3 ampere current will flow. This is for an example. Okay, across the resistor R1, the 3 ampere current will flow. Then across the resistor R2, 2 ampere current will flow. I'll write here, 2 ampere current will flow. Then across the resistor R3, 1 ampere current will flow. 1 ampere current will flow. Entire circuit is 6 ohm. Okay, yes, look at here, but there are 3 paths for current flowing, due to which current gets distributed according Ohm's law, V equal to IR, I equal to V by R. Current is inversely proportional to resistance. So if the resistance value increases, current will decrease. So R1 value, resistance value is very minimum. So 3 ampere current is flowing across the resistor R1. So across the resistor R2, 2 ampere current is flowing, and across the resistor R3, 1 ampere current is flowing. 1 ampere current is flowing. So resistance here, R3 resistance is more, so current is less. R3 resistance is more compared than R1, the current is less. R1 resistance is less, that is the reason why more amount of current is flowing. Is it clear, students? Yes, that's all. Yes sir, okay sir. In parallel combination, current gets distributed, sir. Okay, total current I, the total current I gets distributed in the form of I1, I2 and I3. What is the total current, sir? You may ask me, what is the total current, sir? What is the total current? Look at here, the total current I in series combination. The total current I in series combination, which is equal to, note this point, the sum of individual current flowing through the resistance. That's all. The total, note this point, the total current flowing through the parallel combination, which is equal to sum of individual current, because the total current I gets distributed as in the form of I1, I2 and I3. If we add these 3 values, we can get the total amount of current which is flowing through the parallel combination. Okay, yes. See, the total current which is flowing through the parallel combination, which is equal to sum of individual current flowing through the circuit. Okay, which means I1 plus I2 plus I3. That's all. If we add this all current, we can get the total amount of current which is flowing through this entire circuit, which means parallel circuit, entire parallel circuit. Is it clear, students? Yes. Look at here. What is I1 value, sir? I1 value is 3 ohm. Sorry, 3 ampere. Just now I said I1 across the resistor R1. I1 current is flowing. That I1 current value is 3 ampere. 3 ampere plus. Across the resistor R2, I2 current is flowing. That I2 value is 2 ampere. 2 ampere, yes, plus. Across the resistor R3, the I3 current is flowing. That I3 current value is 1 ohm. 1 ohm. So what is the total value, sir? What is the total value? 3 ohm plus 2 ohm plus, sorry, ampere. 3 ampere plus 2 ampere plus 1 ampere, which is equal to 6 ampere. Yes, this is equal to 6 ampere. So this sum of the all current which is flowing through the each resistor will be equal to total current. Is it clear, student? Yes, that's all. Which is equal to total current. Am I right or wrong? Very easy one. Don't get confusion. Okay, yes. So total current I, that is equal to I1 plus I2 plus I3. If we add this all individual current flowing through the resistance, that is equal to total current which is flowing through the entire circuit. That's all, students. Very easy one. You don't get panic. Okay, yes, that's all about the current, that's all. So in parallel combination, voltage remains same, but current gets distributed. Am I right or wrong? Yes, very easy one. Okay, yes. Shall I explain Tamil? Yes. So இதுதான் parallel combination. இதுதான் parallel combination. So parallel combination என்ன சார் அப்படின்னா ரெசிஸ்டர்ஸ்க்கு ஆல்ரெடி நமக்கு என்ன தெரியும், ரெசிஸ்டர்ஸுக்கு 2 எண்ட் இருக்குது. ஓகே, ஒவ்வொரு ரெசிஸ்டருக்குமே 2 எண்ட் இருக்குது. எஸ். ஸோ ஒவ்வொரு ரெசிஸ்டருடைய ஃபர்ஸ்ட் எண்டுமே எங்கே கனெக்ட் ஆகிருக்கு அப்படின்னா ஒரு பாயிண்ட் கனெக்ட் ஆகிருக்கு. அதே மாதிரி இன்னொரு எண்டு வந்து இன்னொரு பாயிண்டில் கனெக்ட் ஆகிருக்கு. இந்த 2 பாயிண்ட்டுமே டைரெக்டாக பேட்டரியோடைய ப்ளஸ்லையும் மைனஸ்லையும் கனெக்ட் ஆகிருக்கு. பேட்டரியோடைய பாசிட்டிவ் டெர்மினலையும் நெகட்டிவ் டெர்மினலையும் கனெக்ட் ஆகிருக்கு. ஆமாவா? ஸோ ஒவ்வொரு ரெசிஸ்டருடைய 2 எண்டுமே டைரெக்டாக கனெக்ட் ஆகிருக்கு. நோட் திஸ் பாயிண்ட், டைரெக்டாக பேட்டரியோடைய ப்ளஸ்லையும் மைனஸ்லையும் கனெக்ட் ஆகிருக்கு. ஆமாவா இல்லையா? ஆமாம், எஸ். ஸோ நல்லா கவனிச்சுக்கோ. இப்போ வோல்டேஜ் என்ன சார் ஆகும் அப்படின்னா, பேரலல் கனெக்ஷனாக வோல்டேஜ் எப்படி சார் ஆகும் அப்படின்னா, இப்போ இந்த பேட்டரியில் என்ன பண்ணுறோம், நான் 10 வோல்ட் கொடுக்குறேன். இந்த பேட்டரி யூஸ் பண்ணி இந்த என்டையர் சர்க்யூட்டுக்கே நான் வந்து 10 வோல்ட் கொடுக்குறேன். நான் 10 வோல்ட் கொடுத்தேன்னா இந்த ஒவ்வொரு ரெசிஸ்டன்ஸுக்கும் எவ்வளோ வோல்டேஜ் சார் போகும் நீ கேட்கலாம். ஒவ்வொரு வோல்டேஜுக்கும் எவ்வளோ சார், ஒவ்வொரு ரெசிஸ்டன்ஸுக்கும் எவ்வளோ வோல்டேஜ் போகும்னா சேம் 10 வோல்ட் தான் போகும். பேரலல் காம்பினேஷனில் நீ பேட்டரியிலேருந்து எவ்வளோ வோல்டேஜ் கொடுக்குறியோ ஒவ்வொரு ரெசிஸ்டன்ஸ் வழியாகவும் அதே வோல்டேஜ் தான் போகும். நீ பேட்டரி வழியாக 10 வோல்டேஜ் கொடுத்தீங்கன்னா ரெசிஸ்டன்ஸ் R1 வழியாகவும் 10 வோல்ட் தான் போகும், R2 வழியாகவும் 10 வோல்ட் தான் போகும், R3 வழியாகவும் 10 வோல்ட் மட்டும்தான் போகும். ஓகேவா? ஏன் சார் அப்படின்னா இங்கே நல்லா கவனிச்சுக்கோ. இங்கே ரெசிஸ்டன்ஸுடைய ஒவ்வொரு எண்டுமே டைரெக்டாக கனெக்ட் ஆகிருக்கு. பேட்டரியோடைய பாசிட்டிவ்லையும் கனெக்ட் ஆகிருக்கு, இந்த எண்டு வந்து டைரெக்டாக நெகட்டிவில் கனெக்ட் ஆகிருக்கு. அப்போ நம்ம இங்கே என்ன வோல்ட் கொடுக்குறோமோ அதே வோல்ட் தான் ஒவ்வொரு ரெசிஸ்டன்ஸுக்குமே போகும். ஓகேவா? டைரெக்டாக கனெக்ட் ஆகிருக்கனால ஒவ்வொரு ரெசிஸ்டன்ஸுக்குமே போகும். ஆனால் இங்கே பாரு, சீரியஸில் டைரெக்டாக கனெக்ட் ஆகிருக்கா? கிடையாது. இங்கே ரெசிஸ்டன்ஸ் ஃபஸ்ட் ரெசிஸ்டருடைய ஒரு எண்டு மட்டும் பாசிட்டிவ் இருக்குது, இன்னொரு எண்டு எங்கே இருக்குது, லாஸ்ட் ரெசிஸ்டன்ஸ் ஒரு எண்டு மட்டும் நெகட்டிவில் இருக்குது. அப்போ இடையில இருக்கக்கூடிய இந்த எண்டில் எங்கே போச்சு, செகண்ட் ரெசிஸ்டரோட எங்கே எண்டு போச்சு, ஃபர்ஸ்ட் ரெசிஸ்டரோட இன்னொரு எண்டு போச்சு, தேர்ட் ரெசிஸ்டரோட இன்னொரு எங்கே போச்சு, டைரெக்டாக கனெக்ட் ஆகலை. டைரெக்டாக கனெக்ட் அங்கே ஆகலை. புரியுதா? எஸ், டைரெக்டாக கனெக்ட் ஆகலை. ஸோ அதனால் என்ன ஆகும், ஒவ்வொரு ரெசிஸ்டருக்கும் சேம் வோல்டேஜ் போகாது, அங்கே வோல்டேஜ் ட்ராப் ஆகும். இங்கே வோல்டேஜ் எதை டிபெண்ட் பண்ணி இருக்குன்னா, சீரியஸில் வோல்டேஜ் எதை டிபெண்ட் பண்ணி இருக்குன்னா ரெசிஸ்டன்ஸை டிபெண்ட் பண்ணி இருக்கும். ஓகேவா? எஸ். நெக்ஸ்ட் இங்கே பார்த்தீங்கன்னா இங்கே டைரெக்டாக கனெக்ட் ஆகிருக்கு, ஒவ்வொரு டைமும் டைரெக்டாக கனெக்ட் ஆகிறதுனால வோல்டேஜ் ரிமைன் சேம். ஸோ பேரலல் காம்பினேஷனில் நம்ம எவ்வளோ ரெசிஸ்டன்ஸை கனெக்ட் பண்ணாலும் ஒவ்வொரு ரெசிஸ்டன்ஸ் வழியாகவும் சேம் வோல்டேஜ் தான் போகும். நம்ம பேட்டரியில் 10 வோல்ட் கொடுத்தா ஒவ்வொரு ரெசிஸ்டன்ஸ் வழியாக 10 வோல்ட் தான் போகும். நம்ம பேட்டரியில் 20 வோல்ட் கொடுத்தா ஒவ்வொரு ரெசிஸ்டன்ஸ் வழியாகவும் 20 வோல்ட் தான் போகும். இன் பேரலல் காம்பினேஷன். நோட் திஸ் பாயிண்ட், இன் பேரலல் காம்பினேஷனில் மட்டும். ஓகேவா? எஸ். சரி சார், வோல்டேஜ் ஓகே சார், கரண்ட் என்ன சார் ஆகும், கரண்ட் என்ன சார் ஆகும்? நல்லா கவனிச்சுக்கோ. இந்த சர்க்யூட்டில் நான் 10 வோல்ட் பொட்டன்ஷியல் டிஃபரன்ஸ் கொடுக்குறேன். ஆமாவா? நான் 10 வோல்ட் பொட்டன்ஷியல் டிஃபரன்ஸ் கொடுக்குறேன். ஸோ இந்த 10 வோல்ட் பொட்டன்ஷியல் டிஃபரன்ஸில் ஒரு 6 ஆம்பியர் கரண்ட் போகுதுன்னு வச்சுக்கோ. இது ஒரு எக்ஸாம்பிளுக்கு வச்சுக்கோ. எவ்வளோ கரண்ட் போகுது? 6 ஆம்பியர் கரண்ட் போகுது. கரண்ட் எப்பவுமே பாசிட்டிவ்லேருந்து நெகட்டிவ் தான் போகும். நல்லாவே நமக்கு தெரியும், கரண்ட் எப்பவுமே பாசிட்டிவ்லேருந்து நெகட்டிவ் தானே போகும். ஆமாம், எஸ். ஸோ இங்கே பாசிட்டிவ்லேருந்து நெகட்டிவ் போகும். 6 ஆம்பியர் கரண்ட் போகுதா? எஸ். ஸோ இப்படி வரும்போது என்னவோ வந்துகிட்டே இருக்கும். ஸோ இந்த பாயிண்ட்டுக்கு வருது, பாயிண்ட் ஏ வர வரைக்கும் 6 ஆம்பியர் கரண்ட் தான் போகும். நல்லா கவனிச்சுக்கோ. பாயிண்ட் ஏ வர வரைக்கும் 6 ஆம்பியர் கரண்ட் தான் போகும். ஆனால் நல்லா பாரு, இங்கே 3 பாத் இருக்குது. இந்த கரண்ட் போகிறதுக்கு 3 பாத் இருக்குது. இங்கே ஒன்று இருக்குது, இங்கே ஒன்று இருக்குது, இங்கே ஒன்று இருக்குது. அப்போ 6 ஆம்பியர் கரண்ட் போகுமா சார்னா போகாது. ஏன்னா இங்கே 3 டிஃப்ரெண்ட் பாத் இருக்குது. இங்கே டிஃப்ரெண்ட் R1 R2ங்கிற டிஃப்ரெண்ட் ரெசிஸ்டன்ஸ் வேல்யூ இருக்குது. அப்போது சேம் அமௌண்ட் ஆஃப் கரண்ட் போகாது. இங்கே கரண்ட், அதாவது டோட்டல் கரண்ட் I என்னவா மாறும்னா I1 I2 I3 டிஸ்ட்ரிபியூட் ஆகும். ஓகேவா? ஸோ இந்த பாயிண்ட் ஏலேருந்து கரண்ட் வந்து டிஸ்ட்ரிபியூட் ஆகும். ஓகேவா? இந்த கரண்ட் என்ன பண்ணும், டிஸ்ட்ரிபியூட் ஆகும். ஸோ R1 வழியாக I1ங்கிற கரண்ட் போகும். நம்மளுடைய கன்வீனியன்ட்டுக்காக எடுத்துருக்கேன். ஏன்னா இங்கே வந்து டோட்டல் கரண்ட் ஐன்னு போட்டேன், இங்கேயும் ஐன்னு போட முடியாது. ஸோ I1 I2 I3 எடுத்திருக்கேன். ஓகேவா? எஸ். ஸோ ரெசிஸ்டன்ஸ் R1 வழியாக I1ங்கிற கரண்ட் போகுது, R2 வழியாக I2ங்கிற கரண்ட் போகுது, R2 வழியாக I3ங்கிற கரண்ட் போகுது. ஓகேவா ஸ்டூடெண்ட்ஸ்? எஸ். ஸோ டோட்டல், ஆனால் இந்த சர்க்யூட்டில் எவ்வளோ கரண்ட் தான் போகுது, 6 ஆம்பியர் கரண்ட் தான் போகுது. ஓகேவா? ஸோ ஒவ்வொரு ரெசிஸ்டன்ஸ் வழியும் ஒவ்வொரு கரண்ட் வேல்யூ போகுது. இந்த எல்லா கரண்ட் வேல்யூயும் நம்ம ஆட் பண்ணணும்னா இந்த டோட்டல் கரண்ட் வேல்யூக்கு ஈக்குவலாக வரும். அவ்வளோதான், டோட்டல் கரண்ட் வேல்யூக்கு ஈக்குவலாக வரும். தட்ஸ் ஆல். புரியுதா? ஸோ I1 I2 I3 இது மூணுமே ஆட் பண்ணனா டோட்டல் கரண்ட் ஐக்கு ஈக்குவலாக வரும். நான் அதான் கொடுத்துருக்கேன் பாருங்க. ஸோ 6 ஆம்பியர் கரண்ட் போகுது. இங்கே ரெசிஸ்டன்ஸ் வந்து கம்மியாக இருக்கனால கரண்ட் அதிகமாக போகும், ரெசிஸ்டன்ஸ் இங்கே அதிகமாக இருக்கனால கரண்ட் கம்மியாக போகும், ரெசிஸ்டன்ஸ் இங்கே அதிகமாக R3ல ரொம்ப அதிகமாக இருக்கனால கரண்ட் ரொம்ப கம்மியாக தான் போகும். ஓகே. ஸோ ரெசிஸ்டன்ஸ் R1 வழியாக எவ்வளோ கரண்ட் போகுது, 3 ஆம்பியர் கரண்ட் போகுது. R2 வழியா 2 ஆம்பியர் கரண்ட் போகுது, R3 வழியா 1 ஆம்பியர் கரண்ட் போகுது. ஸோ 3 ஆம்பியர் ப்ளஸ் 2 ஆம்பியர் ப்ளஸ் 1 ஆம்பியர் இதெல்லாமே ஆட் பண்ணதுக்கு வரும் 6 ஆம்பியர். இந்த சர்க்யூட்டில் டோட்டல் கரண்ட்டுக்கு ஈக்குவலாக வந்துடும். அவ்வளோதான், ரொம்ப சிம்பிள். ஓகே, அதான் கொடுத்துருக்கேன். தி டோட்டல் கரண்ட் இன் parallel combination is equal to sum of individual current flowing through the individual resistance. That's all. I1 plus I2 plus I3. That's all. ஓகே, இது ஆட் பண்ணால் நமக்கு 6 ஆம்பியருக்கு வரும். தட்ஸ் ஆல். வெரி ஈஸியாக, ரொம்ப 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 சிம்பிள். எதுவுமே காம்ப்ளிகேட் பண்ணிக்காத. ஓகேவா? ஸோ பேரலல் காம்பினேஷனில் வோல்டேஜ் ரிமைன் சேம். நீ எத்தனை ரெசிஸ்டன்ஸ் போட்டாலும் ஒவ்வொரு ரெசிஸ்டன்ஸ் வழியாகவும் சேம் வோல்டேஜ் தான் போகும். அதே கரண்ட் வந்து டிஸ்ட்ரிபியூட் ஆகும். ஹியர் இன் parallel combination current is depend on the resistance value. If the resistance value is more, then current value will be less. If the resistance value is less, current value will be more. That's all. Very easy one. Is that clear? Very easy. Okay, yes. So I rub this. That's all. I'll rub. So next I am going to start resistance, sir. Resistance. What is that? Resistance. Is it clear? Yes. I'll rub this. Unwanted things are there. I'll rub everything. புரியுதா? இவ்வளோதான். ரொம்ப ரொம்ப யோசிக்காத, எதுவுமே இல்லை. ரொம்ப சிம்பிளான மேட்ரு தான். ஓகேவா? எஸ், நல்லா கவனிச்சு. ஓகேவா? ஸோ வாட் இஸ் த கன்க்ளூஷன், சார்? இன் parallel combination, the potential difference remains same, voltage remains same. So whatever the resistance connected in parallel, potential difference remains same. But current gets distributed. Okay, yes. In parallel combination, the current flowing through the resistors is depend on the resistance value. Okay, in parallel combination, the current value is depend on resistance value. If the resistance is more, current will be less. If the resistance is less, current will be more. That's all. Very easy one. Okay, students, very easy. Okay, yes. So we have discussed about voltage and current completed. Next, which is left? Resistance. Which is left? Resistance. Is it clear? Yes, resistance. Now come to this one. Series combination. Come to this series combination. In series combination, what is total resistance, sir? What is total resistance? Just you add the all resistance value, we can get the total resistance value. Because in series combination, all the resistance are connected one after one. So we can easily add the all things, which means all resistance value, we can get the total resistance value. But not this point, but in parallel combination, the all resistors are connected one below one after one. Sorry, not one after one below one. How can we add, sir? We cannot add, sir. Okay, because both are parallel to each other, so we cannot add the all resistance value. Then how can we get the total resistance value in parallel, sir? Okay, look at here. In series, all the resistors are connected one after one, so we can so if we add this all resistance value, we can get the total resistance value, which means R that is equal to R1 plus R2 plus R3. Am I right? Yes, we can get the total resistance value. But in parallel combinations, we cannot do like this. Like this, because the resistors are connected one below one, so we cannot add this all resistance value. Then how can we find out the total resistance value, sir? That is next one. Okay, I'll rub this because I need to make a derivation, so I need that space, so I'm going to rub that. Okay, yes, look at here. See, very easy. The derivations on all the things are very easy one. Okay, you don't get panic. Okay, students, so listen here. So according to Ohm's law, so V equal to IR, we have discussed about voltage. So what happens to voltage when number of resistors are connected in parallel? Then we have discussed about what happens to current when the number of resistors are connected in parallel. Next, we are going to move on what happens to total resistance when the number of resistors are connected in parallel. That is next one. Okay, students, so very easy. Okay, yes, listen here. Next, we are going to see the total resistance value. Total resistance, or otherwise we can say resultant resistance. Both are same here. Resultant resistance. resultant resistance. Okay, very easy. Please don't get panic. In series combination, if we add this all resistance value, we can get the total resistance value. But in parallel, we should not do like that. Okay, we cannot do like that, because here the resistance are placed, which means connected one below one below one, which means 1 by 1. So we cannot add that. Then how can we get the total resistance value, sir? With help of the law of combination of resistors in parallel, we can get the total resistance value. What is that? With help of the law of combination of resistors in parallel, we can get the total resistance value. Is it clear, students? Yes, very easy. Let's get started. Yes. In parallel circuit, which one gets distributed? In parallel combination, which one gets distributed? Yes, current gets distributed. Am I right? In parallel combination, current gets distributed. So which means the total current I, that is equal to sum of individual current flowing through each resistor. I, that is equal to I1 plus I2 plus I3. Am I right? Yes. This total current, which is equal to sum of individual current flowing through each resistor, which means I, that is equal to I1 plus I2 plus I3, because current gets distributed. Am I right? Yes. Consider this is equation 1. Consider that is equation 1. Is it clear, students? Yes. According Ohm's law, V equal to IR. I'll write that. According Ohm's law, V equal to IR. Isn't it? Yes. We need this I value. So I, which is equal to V by R. I, which is equal to V by R. So consider this is equation 2. I, which is equal to V by R. According Ohm's law, just we are going to use only Ohm's law. Just we are going to interchange in all terms. So no one new terms, no one new formula is here. Okay, yes. So I equal to V by R. So according to Ohm's law, V equal to IR, I equal to V by R. So this is equation 2. You just consider that is equation 2. Is it clear, students? Yes. Now come to this parallel combination. In parallel circuit. Look at here, in parallel circuit. Okay. Look at here. This is I1. Okay, consider this R1. Consider a resistor R1. You remaining 2 resistors, you leave it. You leave it the remaining 2 resistors. You just consider the R1 resistor. Yes. So across the R1 resistor, how much amount of current is flowing? Look at here. This is resistor R1. This is a resistor R1. Along this resistor R1, how much current is flowing? Yes, I1 current is flowing. Am I right? Yes. So resistance value is R1. Okay, this resistance no need. I want to confuse panirom. Look at here. You consider resistor R1. So along this resistor R1, how much amount of current is flowing? I1 amount of current is flowing. What is the potential difference? Potential difference remains same. Okay, across the all resistor, potential difference remains same. That is V. Am I right? Yes. Consider potential difference V. Here also potential difference V. Here also potential difference V. Am I right, Ara? Yes. Already we know in parallel combination, potential difference remains same. So look at here. Across the resistor R1, the current value is I1 and potential difference is V. Am I right? Yes. Next one, across the resistor R2, the current value is I2 and potential difference V. Across the resistor R3, the current value is I3 and potential difference is V. Am I right? Yes. All the values are known. Okay. Yes. Look at here. In parallel circuit, the current I, that is already we know the current I, that is equal to V by R. Yes. You first consider resistor R1 and apply this formula here. So I1, because across the resistor I1 current is flowing, so I equal to V by R. So here current value is I1. So I1, that is equal to V value how much? Which means voltage remains same, that is V. So V by resistor, this is first resistor, so that is R1. First resistor R1. Am I right? Yes. Consider this is equation 3. Is it clear? Very easy. Look at here. First you just consider the resistor R1 only. Remaining you two resistors you leave it. Okay, yes, look at here. So across the resistor R1, I1 current is flowing because current gets distributed already, we know in parallel connection current gets distributed. So across the resistor R1, I1 current is flowing. Potential difference same. In parallel circuit potential difference remains same, so potential difference V, just V. There is no distribution, so there is only V, just V. Okay, this. So already we know I equal to V by R. I equal to V by R. So across the resistor R1, what is the I value, current value? Already we know I equal to V by R. So I across the resistor R1, I that is equal to current value that is equal to I1, so which is equal to potential difference V, same potential difference, and resistor R1. That's all. Okay, yes. Next come to this one, second one. So second resistor. So what is the current value? Yes, I2 that is equal to, what is the voltage value? V, same amount of voltage flowing. So V by, then resistance value, resistance is here. So resistance value R2 here. So R2. This is equation 4. Very simple. Okay, in similar manner, come to the resistance R3. Yes, across the resistance R3, how much current is flowing? I3 current is flowing. We need only current value. So I3 that is equal to potential difference V equal to IR. What is V? V is potential difference. So across the resistance R3, what is the potential difference? The same V. So V by, and resistance R3. Yes, resistance R3. This is equation 5. This is equation 5. Very simple. Don't get confusion. Okay, yes. Okay, students. Yes. So we have 5 equations. Equation 1, 2, 3, 4, 5. Am I right? Yes. Look at here. Substitute this equation 2, 3, 4, 5 in equation 1. Equation 1, what is equation 1? I that is equal to I1 plus I2 plus I3. So substitute this all values, okay, which means I value, I1 value, I2 value, I3 value in equation 1. That's all. So substitute equation, what is this? 2, 3, 4 and 5 in equation 1. In equation 1. Is it clear, students? Yes, look at here. According to Ohm's law, already we know I that is equal to V by R. Substitute this value. Substitute this I value in equation 1. So instead of I, we can write V by R. Yes, V by R, which is equal to, what is I1 value, sir? Look at here. I1 value is here. So I1 value is V by R1. V by R1. Then what is I2 value, sir? Plus this I2 value is V by R2. Yes, V by R2 plus, that is plus. What is I3 value? So I3 is equal to V by R3. So V by R3. Is it clear? So we can get V by R which is equal to V by R1 plus V by R2 plus V by R3. In all the terms which is common. All the terms which is common. V is common. Am I right? All the terms V is common. So we can bring out the V. Am I right? Yes. So V into 1 by R. We can write, okay, so Tamil we say V and வெளிய எடுத்துட்டோம். So V into 1 by R which is equal to, you bring out the V. So V, all the terms, okay, V and all the terms V is common, so bring out the V. So we can write 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So look at here, V cancel. Am I right? So V cancel. So what is the value? 1 by R which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is a formula to find out the total resistance in parallel combination. That's all, students. This is a formula to find out the total resistance value in parallel combination. If number of resistors are connected in parallel, this total resistance which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's all. Okay, this is a formula to find out the total resistance value when number of resistors are connected in parallel combination. In parallel combination. Whereas in series combination, the sum of all the individual resistances, which means R that is equal to R1 plus R2 plus R3, that is equal to total resistance in series. But in parallel, the resistance are connected one by one, one below one. So due to which the total resistance, note this point, the total resistance 1 by R, okay, which means the reciprocal of total resistance or combined resistance, which is equal to reciprocal of sum of reciprocal of individual resistances. That's all, students. Very easy one. Okay, so this is a formula to find out the total resistance. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. Okay, so very easy. Okay, this is a formula to find out the total resistance value. Please do this derivation in your class book. This is very important one. Just pause the video and make this all concept, note on the all concept in your class book note. Okay, very easy. So this is a formula to find out the total resistance value. R1 plus 1 by R, which is equal to 1 by R, which is what is 1 by R? This is the total resistance value in parallel. Total resistance value in parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's all. In series, that is equal to R1 plus R2 plus R3. But in series, the resistance are connected one after one. But here, resistance are connected one below one, due to which the total, to find out the total resistance value formula is 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's all. Is it clear, students? Very easy. So what is this meaning, sir? What is this meaning, sir? Look at here. The reciprocal of total resistance, the total resistance of number of resistance connected in series, which is equal to the reciprocal of sum of individual resistances. 1 by, which means reciprocal, the inverse. Am I right? Yes. Look at here. Note down this explanation in your class note, because I don't have space to write here. Okay, yes. The reciprocal of total resistance of number of resistance connected in parallel, which is equal to reciprocal of sum of individual resistances. The reciprocal of sum of individual resistances. That explanation for this concept, this formula. That's all, students. That's all. Very easy one. You don't get confusion. Okay, so what is it, sir? The reciprocal on this point, very important point. You please note on your classbook note. The reciprocal of total resistance of number of resistance are connected in parallel, which is equal to reciprocal of sum of individual resistances. Reciprocal of sum of individual resistances. That is total resistance. Is it clear, students? Very easy, students. Please don't get panic. Okay, the derivations may be difficult. For seeing the derivation will be difficult, but it's very easy one. Just simple mathematical formulas are there. That's all. Okay, students. Yes. So what is the conclusion, sir? Because this session getting over, what is the conclusion, sir? In parallel combination, the potential difference, which means voltage remains same. So whatever the resistance are connected in parallel, the same amount of voltage will be for each and every resistance. Okay, yes. In parallel combination, the resistance remains same, but current gets distributed. Okay, so when two or more resistors are connected in parallel, the current gets distributed. Okay, yes. Then what is the total resistance, sir? The total resistance, which is equal to 1 by R, total resistance 1 by R, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3, which means the reciprocal of a total resistance of number of resistance connected in parallel, which is equal to reciprocal of sum of individual resistances. Reciprocal of sum of individual resistances. Okay, which means 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's a very easy one. Okay, yes. So time is very much more, so it's a very long time. Based on this concept, I'll make numericals, okay, on my next video class. Okay, students. Yes, thank you very much. I hope this class will be very useful for you. Okay, numericals for this concept numerical, I'll put a new video. Okay, students. You wait for that. Okay, students. Thank you, students. If you have any doubts, so mark in your class textbook, and whenever you come to school, you come and meet me, I'll clarify your doubts. Okay, students. Thank you.